Hello class, now that we have gone over problem 7 and problem 9, this problem should be fairly quick to solve. We just got to be very careful with a few things that are asked in the problem. First of all, um, the problem asks us to refer to problem 10, and if you notice, this is a minimization problem. Okay, therefore, we know already this is not profit, this is not revenue. You couldn't possibly have a boss that tells you, can you tell me how to minimize my profit, minimize my revenue? And if you keep reading, you're going to notice it talks about risk index. So it's talking about minimizing risk index for a stock fund, for two different stock funds. In this case, S, and then we have M, okay? So cost, so the stock fund S and this stock fund M. If you do remember, I did just cover about allowable decrease and allowable increase. In this problem, when you read, you're going to notice that really it's all referring to my objective coefficients. What the book does not tell you, and the book does not specify, which could be tricky if I ask you on your final exam, for example, when we're talking about an optimal solution, optimal solution, if you remember, I told you, is composed of two parts. It's composed of your objective values of your coefficients and also the actual optimal objective value, the total that you get from using your optimal objective values right here. You give this much. Okay, so let's start the problem and you hopefully will understand better what I'm saying. Right here says suppose the risk index for the stock fund S increased from its current value of 8 to 12. So this is instead of 8, now is a 12. How does the optimal solution change, if at all? Well, the book is not really specifying, so I would assume it's only referring to this part over here. But again, optimal solution, it refers to the whole results, because when you go to your boss, you're not going to tell him, well, we need 4,000 of stock fund S and we need 10,000 of stock fund M, but I'm not really giving him the value of that. And I'm sure that wouldn't be appreciated. So what we need to do first is to determine the range. Once we determine the ranges, we can answer this fairly easily. So right here, my objective coefficient 8 and my objective coefficient 3, and it's telling you that your range is how much you can decrease to stay into your range of optimality. Right here would be a decrease right here. So let's start. If we have an 8 and I can decrease 4.25, so that's the minimum I can go. And right here for my increase, I have an infinite. Therefore, my 8 plus my infinite, we're just going to put the symbol over here. So as long as I stay on this range over here for the coefficients, everything would be fine. So now let's do for the second one, for the index right here, M. So we have a 3, correct? Right here, 3, right? Minus, first let's do the decrease. Oh, it's infinite, so really we know it would be a negative infinite actually, but I can't do it that because Excel see what it does. So let me go ahead and see if I can do a space. Still doesn't take it. Let's put in red in this case. So over here on my right side, my increase is gonna be 3 plus my 3.4 over here. Increase, right? Which is so 6.4. So these are my ranges for my coefficients to get a 62,000 value. Okay, so now let's answer the questions. Well, if you just answer based on your coefficients, if you increase your value from 8 to 12, how does the optimal solution change? Well, if your increase, and put like this, decrease, increase, this is for S and this is for M. If your allow to increase up to infinity. So really shouldn't be no change. So you can say no change in the coefficients of the optimal function, correct? There is no upper limit for the range of optimality. Optimality, sorry, for the objective coefficient for S. However, if you would be asked for an actual value, that would change because now you're working with 12,000 and then you have 4,000 shares plus 3 remains the same. I'm getting the 4,000 and 10,000 right here. And this is the value 62. So 3 times 10, that's 78 now. So if you want to give a complete answer, you can say there is no change on in the coefficient of the optimal function. No change in the coefficients of the optimal function since it is in the range of optimality. There is no limit. There is no upper limit for the range of optimality for the objective coefficient for S. However, your value does goes from 62,000 now to 78,000. Okay, so we are just gonna go by the coefficient because this are really, it should be saying right here, just it should be noting right here coefficient. So right here B, so now it's asking us, suppose that we change m increases from its current value 3 to 3.5. Please note it that you're not adding this. It's going from 3 to 3.5. So you're replacing this value right here for 3.5. Well, 3.5, your range for m is between infinite 6.4. So you're completely within the range. Therefore, no change in the optimal. I'm just gonna put it the way they're asking solution. The objective coefficient for m can increase to 6.4, or you could put it the same way over here and say there is no upper limit, which we did put just in a different way. So let's suppose now they both increase. S increased to 12 and m increased to 3.5 at the same time. How does the optimal solution change, if at all? Well, if we're just referring to the coefficients, therefore the optimal solution does not change, correct? Well, if it goes from 8 to 12, well, infinite is increase, and we increase from 3 to 3.5, 6.4 is my max, therefore the optimal solution does not change. And then we'll be done with problem 11.